Okay, and here we go. Hello, I'm Jonathan Alcorn, and this is just a quick video to introduce you to my YouTube channel, mechanicaldesignengineer.uk. I am a mechanical design engineer and I'm based in the UK, hence the title of the YouTube channel. The whole purpose of this channel is to help engineers young and old, mechanical design engineers that is, not so much with the stuff that you have all over the internet, which is things like finite element analysis and stress and strains and all that good stuff. Torque calculations, whatever, that's all run-of-the-mill stuff, we can do all that, that's fine. What I'm going to do with this channel is to show you how to actually properly engineer components. I specialise in machinery. I'm a machinery design engineer. Detail design engineer is my speciality. What that means is I design components and assemblies for machines. The machine, to give you some idea of scale of the machinery I do, it's basically packaging machinery, food processing machinery, that kind of thing. No experience with aircraft, nothing of automotive. They're very specialist areas, as is mine. To each his own. I keep my nose out of their business. I just do my thing, which is machinery design. So that's the introduction. That's what we're going to be doing. And essentially, the main thrust is, or the reason is quite simple. That in the last 5 years, in particular, I've noticed with the full adoption now of 3D CAD. Client companies are employing staff who are very good at driving 3D CAD, Solid Edge, SolidWorks, Inventor, you name it. Great stuff to do, great models and everything else. What's happening is that things are falling down a little bit on the execution of those designs, namely the actual engineering drawings that come out at the end. Quite often they're almost an afterthought. The level of draftsmanship is extremely poor, so I'll be touching on that, but the main thing I want to share with you is the experience I've had over the last 40 years of my career working for some of the top-notch engineering companies, global companies that were based here in the UK. My career started in the mid-1980s in earnest. I worked at Metal Box, Rose Grove, Boxford, lots of different companies who taught me a lot. Taught me an awful lot, and while I was contracting, I was a contract design engineer, so therefore I was able to go around and see lots of different companies, see what they were doing, and learn from them. And I actually built up a dossier. I've got 3 folders here of various engineering standards, which quite frankly are worth the weight in whatever, because in here this is how you design machinery. These are the tolerances, these are the methods used, the methods of selecting the right materials. It's all in here. This tends to be things that isn't taught very often these days. It is a classic unknown, yeah, so basically I intend to share this with you, and quite a lot of this was, I say, was taken from companies with their permission, I might add. I photocopied these way back in the day, and have used them ever since. It's a question of appropriateness. It's the appropriate application of tolerances in particular. I'm just trying to have a look through now. So for instance here's a nice one here, for instance. So this one here is a little example from a company I work for. Now, what they've done here is they've given, so this is obviously what we used to call an Allen cap, it's now called a solid socket set screw, but same thing. And it gives all the dimensions of it, which you think, well, that's a bit over the top, but not really, no, because you can then use this document to very accurately and precisely design around it. So they make the counterbore very tight if you want to, if you want to have a counterbore, etc, etc. And so this is just one example, and where else have we got in here? Here for now, this is a good example. Okay, so here, counterbores. So here we have the different counterbores here, and here we have the typical standard to go with it. So this is a standard. Yeah, this is a standard that this particular company used and which I've used ever since. It looks really nice. Really good men have done this. These were probably put together in the 1950s or 1960s by proper white coated engineers, okay, who really knew what they were talking about and what they were doing. They would have had meeting after meeting and thrashing out every single dimension on these pages, okay, to get the perfect result, which is a blend of quality and cost, appropriate cost. And as we know, those machines were second to none. The other one I wanted to quickly share with you now, before I finish this introductory video, is this here. Bear with me 1 second. So let's have a look. So here we are. Right, this one here. Now this piece of paper here has been used so many times it is ridiculous. So here. Right. So what you have here is, you can see here you have the holes and then you have the shafts, and it's the interaction between the hole and the shaft, okay? So what that talks about is the nominal size, okay, the hole limits, which they always use H7 for the hole limits. We've got that on here. And then shaft limits, and then we have 3 types of shaft, or 3 types of fit. We have running fit, easy push fit, and dry fit. So these are really nice, simple terms to understand. Nice, simple terms to get your head around on here. Okay, and you can see here's a nice range. You've got running fit, easy push fit, dry fit. And I've made a little note there, way back in the day, how on a whole, the upper dimension is the smaller dimension of the two because it's maximum metal condition. When was the last time you heard that name, that word, that phrase? And on the shaft here, you have the high or the upper, the larger dimension on the top, maximum metal condition, okay? So these little tips here, right? Now, the other benefit, of course, is that if you produce proper engineering drawings that are properly annotated and dimensioned and make sense, what will then happen is the machine shop will realise that you know what you're doing and not constantly be on the phone questioning everything you've done, because they wonder, does this guy know what he's doing? So here, for instance, is all the circlips, all the circlip sizes and everything else. And you'll be saying, oh yes, but we can get all that on the internet. Well, yes, you can get all on the internet. Yes, off you toddle. You go and get it. These here are the actual dimensions that you should be using for optimum life, optimum wear characteristics. I mean, here, look, here, there's even a thing here of, you know, it gives you an idea of the shaft inside the hole, or what sort of tolerance to allow for any jiffle, as we used to say. Okay, so there we go. So that's just a brief introduction to this little channel and what I'm all about. If you have any comments, please go ahead and do that. Share any content that you like with any of your friends and colleagues and what have you. But as I say, the main thrust of the channel is going to be practical application, how to design components, how to select correct materials, how to tolerance properly, how to apply tolerances properly, and not just the theoretical stuff, not just the academic stuff, because we all know that academic means of no practical use. That's one of the definitions of academic. What this is this is proper engineering applied to your design. So you go ahead, you design your machine, you do your great job that you are doing. You can use this channel to help you guide, help you tolerance those drawings properly and get the most out of those parts, so that they last a good length of time. I'm available for consulting work. I'm available for design work if you want as well. Any advice, whatever else, I'm always here. Give me a shout. The contact details are on the bottom of on the contact section. But anyway, that's enough for now. Thank you for watching my introductory video, and I hope you enjoy the content as and when I upload it. Thank you.